All right, today we're talking about both lessons 2-2 and 2-3. 2-2 is mainly going to be a look at vocabulary words. And then 2-3 we'll be talking about how to solve an equation by either adding or subtracting. So let's start off with our vocabulary words. We have 3 to begin with. Equation, which is a mathematical sentence with an equal sign. Remember in lesson 1 we talked about an algebraic expression, which is a phrase. It doesn't have an equal sign. It's not complete. An equation is complete. It has an equal sign. So 3 plus 5 equals 8. That would be an example of an equation. An open sentence is an equation with one or more variables. So 3 plus 5 equals 8 is an equation, but it's not an open sentence because I don't have a variable in it. If I had t plus 3 equals 8, that would be an equation and it would be an open sentence. It would be both. A solution of an equation is simply a statement that tells you the value for any variable that will make a solution or make an equation true. So if you had t plus 3 equals 8, the solution would be t equals 5. So when t, in the open sentence t plus 3 equals 8, when t has a value of 5, it makes it true. So that would be called a solution. So how do we know if a number is a solution? You simply plug it in and try it out. If you had something that you couldn't just tell by looking, here we have 27 times m, that's our variable, equals 567. So is the solution 8? Is it 11? Or is it 21? You just try all 3 out. So if you substitute the m with 8 and multiply that out, we get 216, not 567. So 8's not a solution for m. How about 11? Nope. When we substitute 11 in for m and multiply it by 27, we get 297. So 11 is not a solution. How about 21? Yes, that works. When I substitute 21 in for the variable m, I do get 567. So 21 is a solution, and the way you write that is m, that's the variable they gave you, equals 21. So that is how you write a solution. In this chapter, we are talking about 2 properties. They both are very similar, just with different operations. They're properties of equality. Basically, they both say that if you do the same thing to each side of an equation, or each side of the equal sign in a mathematical equation, then they're still equal. So in the addition property of equality, if you add the same value to both sides of an equation, the 2 sides are still equal. So if you have 14 times 2 equals 28, that's our mathematical equation. And then we add a 5 to both sides. We add a 5 to the 4 times 2 side, and we add a 5 to the 28 side. They're still going to be equal. So here is our statement with that, showing any number. If any number a is equal to any number b, and we add a value of c to each side of the equation, they'll still be equal. It'll still show equality. The same is true for the property of subtraction. If you subtract the same value from each side, then it will still be equal. That's important because if we don't have those properties of equality, we can't do the next thing we're going to look at, which is called how to solve an algebraic equation using inverse operation. The word inverse means opposite. So inverse operations are operations that undo each other. So addition undoes subtraction. Subtraction undoes addition. Multiplication undoes division. Division undoes multiplication. So, if we had 8, then we added 3, and then we subtracted 3, we would go back to what we started with. That's why they're called inverse operations. They undo each other. You get what you start with. If you do one thing and then its opposite, you go back to what you started with. Okay, so how do we solve an equation with this information? You look at what operation is being used in the equation to start with. Is it addition? Is it subtraction? Use the inverse of that with whatever number they're using on each side of the operation or each side of the equal sign. And then you write your solution. So let's look at an example. If we had y minus 4 equals 20, the operation being used is subtraction. So how do we undo subtraction? We add. We're going to add whatever number is being subtracted. So we're going to add 4 to this side of the equal sign, and we're going to add 4 to that side of the equal sign. So then if we took a y and we subtracted 4, but then we added 4, we'd go back to just having the y. On this side, we have to take the 20 and add the 4. And so this is called our solution, y equals 24. Here's another one. And remember, now that we have those integers, they're going to show up everywhere. So n plus 6 equals negative 10. Our operation being used is addition. We're using a 6 with that addition. So to undo it, we do the inverse. We subtract 6. So we put subtract 6 on this side of the equal sign, and we put it on this side. We do always have to put it after whatever's already there. And that's important because now that we have integers, that will make a difference. Remember, we don't have a subtraction property that's commutative. So it does make a difference which one comes first. Negative 10 minus 6 would be like negative 6. Remember, we add the opposite. So we're going to change minus to plus and 6 to negative 6. So negative 10 plus negative 6 is negative 16. So our value for n is negative 16. Okay. One more example here. What operation? We have subtraction. We have it with a 3. So we're going to inverse operation, add 3. And we're going to do that on each side of our equal sign. We simplify. If I took a c, I subtracted 3 and then I added 3, all I'd have left would be the c. Simplify, negative 8 plus 3 is a negative 5. All right, it's time for you to try some practice problems. Remember to try to keep the two things separate. Do the algebra by setting up all of your inverse operations. Then, if you have integers and some negative numbers in there, you need to remember what we learned from chapter 1 to solve that part. Good luck.